Hello and welcome to the fifth lesson in Unit 5, and today we're looking at making a comparison between linear, quadratic, exponential. So linear we are talking about from grade 9, quadratic we're talking about what we've learned in grade 10 and 11, and now you're just doing your introduction to exponential, so it's your knowledge and skills from grade 11. So now it's just identifying or being able to tell the difference between these three different functions. So your goal today, I can explain the difference between linear, quadratic, and exponential and their growth of their applications. So we are going to look at comparing them, and the first thing we want to do is compare them graphically. So for this part, I'm going to go to Desmos because it is much quicker to do the comparison. You can see all three plotted together. So I'm going to slip to Desmos, and we'll make a sketch of these once we're done our comparison. So going to use Desmos to create three graphs. So the first one, I'm just going to go y equals 2x. So y equals 2x. So we've seen this before in the grade 9 course and grade 10 course to a certain extent. Alright, and we know that we can change the steepness or the slope of the line by changing the m value. Okay, so there is your standard linear equation. What do we know about a linear equation? Using my pointer here, you can see that you go over and up at a constant rate or a unit rate. Alright, so it is always increasing or decreasing at a constant rate. So if we add in another equation, if we add in a quadratic, so y equals, let's go with x squared, and I think what I'm going to do below, I'm going to get rid of that factor of 2, so that is the base function for each one. So now when we look at the comparison, or look at the two of them, a line continues in either direction infinitely at a constant rate. So you have your step pattern, one-to-one step pattern. A parabola is a symmetrical shape that has a min or a max. Alright, we talked about this in Unit 2, a min or a max, so it either opens up or down. And you can see that for the first segment of the quadratic, it's slower increasing in y value, but eventually it overtakes or passes how fast the y values increase in a linear function. So a quadratic definitely increases in a much faster manner. The last one we're going to look at then, the third one, is our exponential. So y equals, and we'll go with a base one, so 2 to the exponent x. And we can see with our green function here, alright, that for the first segment here it's faster, increasing faster than the quadratic, but then the quadratic overtakes it. If I shrink this down, we see that the exponential suddenly passes or surpasses in terms of rate. So you can see that the quadratic, the blue line, is definitely not gaining or increasing in value as fast as the exponential or green one. So we can see the difference between the three, okay, using Desmos. And so if we go back to your note then and put in what we need to for study or knowledge purposes, our linear, so let's start with that. So our linear is going to be the first one. It is a line that continues infinitely in both directions, and you can have a positive slope, so an increasing function, or you can have a negative slope or a decreasing function. With a quadratic, it is symmetrical, so you can have a shape that looks like that, or you can have a shape that looks like that. So those are your kind of your two options, opening up, opening down. Not quite the same as a positive and negative slope, but it's a similar concept in terms of, which direction is the resulting graph heading. And finally, our exponential graph, our last one and newest member of the team here, we can have an increasing function. It's going to look like that, or we have a decreasing function that looks like that. All right. So just a couple of notes that we talked about already when we were looking at Desmos. So our linear, okay, it increases, decreases at a constant rate. Alright, so it increases, decreases at a constant rate, and it increases the slowest. Okay, it has the slowest gains. Whereas a quadratic, hey, it increases or decreases according to our step pattern. So if you think back to unit number 2, to our step pattern, remember we had the over 1 up 2, over 1 and so on and so forth. So it over 1 up 1, over 1, or sorry, over 2 and up 4, over 3 up 9. Okay, so it goes up according to that. And our exponential, well, it's going to increase the fastest. So I guess I'll put increase, decrease the fastest. So increase, decrease the fastest. Now you should be able to look at the 3 graphs and be able to identify them. Okay, so you can see that if it forms a straight line, we know obviously it's linear. If we get that parabolic curve, we have a quadratic. And an exponential isn't symmetrical like the parabola. So if you see it tail off and hit an asymptote, then you know you've got an exponential. All right, so there it is graphically. With equations, it's very, very simple to remember. So for linear, x and y must have an exponent, have an exponent of 1, and be in the numerator. All right. So if we're looking in terms of the equation, it has to have exponents of 1. So some examples for you. Y equals x over 3, y equals negative 5x plus 1. So there is our rule for the linear one. All right. As we move on then to our quadratic. So our quadratic, I'm going to put right here. Actually, let me reword that. So we'll say y must have an exponent of 1 and x must have an exponent of 2, must have an exponent of 2, and be in the numerator. Okay, and then our third and final one here, y equals 2 to the x for an exponential. It must be x must be part of the exponent. And when I ask you to justify or explain your reasons why it's linear, quadratic, that's what you're going to write for me. X is in the exponent, therefore it's an exponential. The x is squared, so it must be quadratic. And that's all there really is to be able to tell the difference between an exponential, a linear, and a quadratic. Third and final one is if I give you a table of values. So if you flip over, here are the 3 functions that we're interested in. You may want to pause it to get these x values written down. So I've put some x values in. I'm going to fill in the y values now. I'm going to go through the steps on how you can tell if you're just given the table of values. All right, so that's if we're just given the table of values. So we will get this on, if I can do that, draw them properly. So negative 3, 1, 3, 5, 7, 9. So I'm just going to take a minute. I'm going to look at the linear one. So this is where we're going to do first differences. Okay. So we create an FD column, our first difference column, and we're finding the pattern that's happening in our y values. So we find that the step pattern, or the pattern that develops in our y values, is plus 2. Alright, so if we have a constant rate, if we have a constant rate. It is linear. So if it's plus 7s minus 8s, okay, it has to be the exact same on each step, then we have a linear function. If we look at our quadratic, so I fill in my table here, so that would be a 3, 1 minus 1 is 0, negative 1, 3, 4, oops, my mistake, should go 0, 3, and 8. So again, we're going to go through and we're going to create our first difference column and find our first differences. So this is what we're given. We see that we have 3 to 0. So we're subtracting 3, subtracting 1, and then negative 1 take away 0 is negative 1, negative 3, and negative 5. So we have symmetry, but the problem is if you don't have symmetry, if you don't see the symmetry right away, depends on what coordinates you pick for your parabola, you may not be able to see the symmetry. So what we need to do is we need to go ahead and take a second first difference column. Alright, so if I take a second first difference column, so negative 3, take away negative 1, so that's like adding, so that would be a negative 2, negative 1, subtract negative 1, 0, negative 1, subtract negative 3 would be plus 2, and negative 3 subtract negative 5 is plus 2. So negative 1 take away would be plus 2, that would be plus 2, negative 3 take away negative 1. I'm just double checking my math here. So we start seeing that, we start seeing a pattern of our 2's here. Alright, so we can see that we have quadratic because that second first difference, our second first difference produces a constant rate. So we see we're going to have plus 2's on this side, and up here, if we go the other direction, we negative 2's. Alright. Last one I want to look at then is our exponential. How can you tell that you have an exponential? So again, filling in my values here, I'm going to have negative 0.25, negative 0.5, 1, 2, 4, and 8. So when we look at this, we know our first differences are not going, they're not going to stand out. Okay, so it's not really our first difference, it is our constant rate. So when you get into the grade 12 course, when you look at this, you're going to say, okay, down here I see the pattern, because as I go from one to the next, I am multiplying by 2. So then if we go back and we do a quarter and we double it, that gives us 0.5, half times 2. So we find that all we're doing here is we're multiplying by 2. It could be multiplying by 3, but it goes back to what the base is for your function. So because this is base 2, you're going to be multiplying by 2. If it was base 3, you'd be multiplying by base 3. So we have an exponential function, exponential if the values are being multiplied by a constant. And it can be decimals, okay? So you may have to do a bit of division in order to figure that out. Alright, so what we would do is, if you weren't sure, down below here, I would take those two values and go 8 divided by 4 is 2. So then 4 divided by 2 is 2. That way, if it's a decimal value, then you're okay because you're testing each one to see if it produces the same quotient when you do your division. Alright, so that's what when you go through the homework, what you need to be able to do is to explain or articulate why a particular function is linear, quadratic, or exponential based on whether I give you a graph, an equation, or a table of values. Good luck. If you have any questions, let me know.